Assuming you're walking on the road and you saw a number written this way on a symbol, now what do you think this number is? What do you think this particular number is telling you? It means 2 times 2 times 2 times 2 times 2. But if I were you, if I see this number, I'll be thinking of, okay, how do I represent this number? I can represent it this way: 2. Then count number of 2 here that appear here. 1, 2, 3, 4, 5, 6, 7. I'll go raise power 7. So I can just say 2 raised to the power 7 instead of me writing 2 times 2 times 2 times 2 times 2 times 2. This is 2 raised to the power 7 in a simpler way. Okay, so this is what will lead us to indices, or we'll call it power. Okay, now what is indices? So my own definition, indices is a superscript or power of a number indicating its appearance. As we said earlier, we have 2 raised to the power 5. Okay? Now it means this 2 is appearing how many times? 5 times. This is called the indices, or the power. So here we have the indices here. You can call it power, but in English it's called superscript. Okay? And this number here is called the base. Okay? Now in indices there are rules we must follow if we want to apply indices in maths. Okay? And those rules are called law of indices. Law of indices. Okay? And the first law, say multiplication law. So the first law is called multiplication law. Now let's assume we have a raised to the power 4, and this a raised to the power 4 means a times a times a times a into 4 places: 1, 2, 3, 4. Okay? And let's say we have a raised to the power 6. This a raised to the power 6 means a times a times a times a times a. Is it up to 6? 1, 2, 3, 4, 5, and 6. Okay? Now we want to multiply. We can say a raised to the power 4 times a raised to the power 6 equals to, this a raised to the power 4 means a times a times a times a into 4 places. Then your multiplication side, let me write this bigger than the other so you understand where it stops. Then this a raised to the power 6 means a times a times a times a times a is how many? 1, 2, 3, 4, 5. Remaining 1 times a. Okay? Now add everything together: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is same as a times 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 a equal to, how many a's do we have here? We have, what is being repeated here is just a. So how many times does this particular alphabet repeat? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a raised to the power 10. Okay? Are we following? So it means a raised to the power 4 times a raised to the power 6 equals to a raised to the power 10. Okay? So we can say, therefore, when you have a raised to the power n times a raised to the power m is equal to a raised to the power m plus n. Okay, so this is the formula for multiplication. So when it comes to multiplication, you add the power. Okay? When in between the base we have multiplication, the power you add it. So let's say for multiplication, we add the powers. Okay, is that clear? So let's take an example. Example 1. This is simplify 5 raised to power 3 times 5 raised to power 4. Now we have to simplify this, make it simple. So we must get the solution. So we have to say solution. We have 5 raised to power 3 times 5 raised to power 4 is equal to. Now remember, we can do it this way, okay? But it will take us time. In mathematics, we find a way to solve things. In an easier way, okay? If we use this one, we waste time. So we have to repeat this one 5 times, 5 times, 5 to 3 places, and 5 times, 5 to 4 places before we add. But we'll just use this formula. This formula here make things easier for us, okay? So since look at the base are equal. Now you take one of the base. Then in between the base is multiplication, and for multiplication we say for multiplication we add the power. So we are going to add the power here. Is 3 plus 4, and this gives us 5. 3 plus 4 is 7, so this is 5. So it means 5 raised to power 3 times 5 raised to power 4 equals to 5 raised to power 7. So this is the answer here. So let's go to the second law, which is the division law. Second, the division law. Okay. Let's say we have a raised to power 5. A raised to power 5 means a times a times a times a times a is up to 5. 1, 2, 3, 4, 5. And let's say we have a raised to power 2 is a times a. Okay? And we are dividing is a raised to power 5 all over a raised to power 2. A raised to power 5 is simple as a times a times a times a times a. 1, 2, 3, 4, 5. So it's complete. Divide by a raised to power. A raised to power 2 is simple as a times a. So we are going to cancel out. Okay? A will cancel a here. A will cancel a here. We are left with just 1 here. So this is equal to a times a times a all over 1. This is same thing as a times a times a, because anything divided by 1 is still the same thing as that particular thing. Okay? So it means a, okay, let's represent this in index form. Is a times a times a is the same as a raised to power 3. So it means a raised to power 5 all over a raised to power 2 equals to a raised to power 3. Okay, are we following? So we can take it this way. Watch. When we have a raised to power 5 divided by a raised to power 2. This is same as a raised to power 5 minus 2. Okay, because cancelling here means you have to take away 2 from this power here. Okay, so this gives us a raised to power 5 minus 2, you get 3. So this is a raised to power 3. Okay, so the formula states that when you have a raised to power n divided by a raised to power m equals to a raised to power n minus m. So this is the formula. Okay, so why I explain this one, just to know that this here and this here are the same thing. This is division sign and this also is division sign. Okay, so if you watch, the answers are the same. The number we use here are the same. So preferably we use this formula to get our answer easier. Okay, so let's take an example so we'll see what we are talking about. This example, okay, let me just write something down. For division, we subtract the powers. Okay, be careful of these statements. For division, we subtract the power. Okay, now example 2. This is not example 1. So let's go to example 2. Example 2 says solve 3 raised to the power of 9 divided by 3 raised to the power of 3. So let's get our solution. Okay, so we use this formula to get our solution. Is 3 raised to the power of 9 divided by 3 raised to the power of 3. This is equal to, the base are equal. Please note the base must be equal. This base must be equal. Okay, now the base are equal. You take one of the base, then the power. What do you do to the power? What will tell you what to do with the power is the sign between this division. So the power now we're going to subtract, because we say for division we subtract the power. Okay, so we have 9 minus 3, and this is equal to 3. What is 9 minus 3? You get 6. So it equals to 6. Okay, so it means 3 raised to the power of 9 divided by 3 raised to the power of 3 equal to 3 raised to the power of 6. So this is the solution to this. Okay, so let's go to the next law, which is the power law. The power law. Okay, number 3. Power law. Let's say we have a raised to the power of 4 raised to the power of 2. This is simple as saying a raised to the power of 4 times a raised to the power of 4. This a raised to the power of 4 is appearing 2 times. Okay, so if you follow your first rule here, let's just assume if you follow your first rule here, which is the multiplication rule, the power there will be 8 because this thing is multiplication, so we add the power here. But this is what we do under multiplication power law. You just say a raised to the power of 4 times 2, and which is a raised to the power of 8. So if you follow your first law, you get the same thing. If you use this formula under this, you get the same thing. Okay, but for power law, you have to multiply the power. You multiply the power. Okay, so a raised to the power of 4 power 2, same as a raised to the power of 8 is 4 times 2. You get 8. Okay, is that taken? So let's state the formula. Therefore, you have a raised to the power of n power m is equal to a raised to the power of n m. What you're seeing here, n and m is multiplying. Okay, so let's take an example. See, I will know what we are doing. This is example 2. So let's go to example 3. Example 3. Okay, example 3 says find the meaning. Sometimes mathematics can be confusing. The first example says simplify. This one says solve. Why this one says find the meaning? So they are talking the same thing. Find the meaning of 5 raised to the power of 3 power 2. This one is easier. Okay, so let's get the solution. Solution is 5 raised to the power of 3 open bracket 2. This is 3 here. Sorry, handwriting is tiny. Okay, handwriting looks like me. Okay, so we just have to multiply. We say 5 raised to the power of 3 times 2 is simple as 5. 3 times 2 is what? 6. You put your 6 here. Okay, so it means 5 raised to the power of 3 power 2 is equal to 5 raised power 6. Okay, is that taken? So let's go to the fourth law. This is zero index or zero power. The fourth, zero index or power law. You can say zero index law or zero power law. Okay, so pick any one among them. Okay, let's say we have a raised power 2 equals to a times a, and here we have a raised power 2. This a times a, and let's assume that we are dividing this a raised power 2 all over a raised power 2. A raised power 2 here is a times a. A raised power 2 here is a times a as well. So this will cancel this will cancel this. You are left with 1 all over 1. So this is same thing as 1, right? So it means a raised power 2 divided by a raised power 2 equal to 1. Now let's take it this way around. If I have a raised power 2 divided by a raised power 2, this statement and this statement are the same thing. No difference, but just that the pattern in which I represent division sign is just different. Without they are saying the same thing, okay? So if we apply our second law, remember our second law, there is the division law. If we apply our second law, which is division law, so we'll be having a raised power of 2 minus 2. So what is 2 minus 2? 0. So this is a raised power of 0. So it means a raised power of 2 divided by a raised power of 2 equals to a raised power of 0. But watch, this statement here and this statement are the same thing. This statement here and this statement are the same thing. But the result here is 1 and the result here is 1. So it means this a raised power of 0 equals to 1. Okay? I don't know if you understand. So it means what we're having here is just 1. Okay? What we're having here is just 1. Okay? So it means a raised power of 0 equals to 1. So let me. So therefore, a raised power of 0 equals to 1. Please, this a can represent any number. Okay? Any number you think of. Now note. Let me give you notes. Any number raised to power 0 is equal to 1. Any number raised to power 0 is equal to 1. Okay? Now, this is example 3. Let's go to example 4. Example 4. Example 4 says find the meaning of 8 raised to power 2 divided by 8 raised to power 2. Okay? Or let's just use 3. 8 raised to power 3 divided by 8 raised to power 3. So solution. So we have to get the solution. Is 8 raised to power 3 divided by 8 raised to power 3 is equal to, if we apply our division law, we're having 8 here, take one of the base, then we'll subtract the power, because we say for division we have to subtract the power. So we'll subtract the power. So this is 3 minus 3 is equal to 8 raised to power 0. So this law says 0 index law. Okay? And here it says a raised to power 0 equals 1. And here we give a note saying any number raised to power 0 equals to 1. So here we have 8 raised to power 0. So this is equal to what? 1. So we can say 8 raised to power 3 divided by 8 raised to power 3 equals 1. Okay? So let's go to the fifth law, which is the fractional index law. The fifth law, which is the fractional index law. The fifth law, fractional index law. So you know what fractional means? Fractional means a number that is having a numerator and denominator, okay? So let's assume we have a raised power 1 over 3, okay? Please, we need to listen more carefully here because this is sometimes confusing. Even when I was in secondary school, it took me time to understand this, okay? So, to my own best explanation, this is how you're going to do it. You put a symbol like this. The base will be inside. Okay? Now, on this fraction, we have 1 all over 3. This is your numerator. And this your denominator. Okay? Now your denominator should be here, while your numerator will be the power. Okay? So let me put your denominator is the root. Don't worry, I'll write the notes down. Then your numerator comes the power. Okay? So remember, a number raised to the power of 1, still that number. Just like when you have 2 raised to the power of 1. 2 is appearing 1 time, so just put 2. Okay? So what we have is cube root of a. Okay? So it means a raised to the power of 1 all over 3 equals to cube root of a. Okay? Now let me cite another example. Is not all number that should appear. There is a particular number that when you are writing, it doesn't appear here. And that number is root. When you hear root, see something as 2. Okay? When you hear root, see something as 2. Okay? So I have a raised to the power of 1 all over 2. So do the same thing that we did here. You put this symbol, is square root symbol. Why I call it square root symbol? Because it's 2 automatically. So I meant to put 2 here because the denominator here is 2, but you shouldn't put 2. All mathematicians know that what should be here is 2, and the 2 is invisible. Okay? So we just put our a here, raised to the power of 1. So this is something as square root of a. So it means a raised to the power of 1 all over 2 equals to square root of a. Is that taken? Okay, now let me cite another example. This example are quite different. This is another example. And I have a raised to the power of 5 all over 3. Now this is something as a raised to the power of 1 all over 3 raised to the power of 5. Do we agree with that? Yeah, because this 1 multiplied 5 is still 5 all over 3. Okay? Now, what we have here, we say a raised to the power of 1 all over 3 equals to this. So, what we have here is just square root of, cube root of a raised to the power, then the power here, which is 5. What is inside here is a raised to the power 1 over 3. This is a raised to the power, and a raised to the power 3 is equal to this. So, we put a raised to the power 1 over 3 there. Raised to the power of 5. So it means automatically the numerator becomes the power. Here, look at, it's not the numerator that is here. So the numerator becomes the power. Okay, so you shouldn't be confused for what I did here. Okay, so this, let me even put it this way. So this is something as a raised to the power of 5 all over 3 because you put your square root symbol. What should be here? The denominator. And the denominator is 3, you put 3. Your base should be inside. Open and close brackets. The power the numerator, which is 5, you put 5 here. So which is the same thing. Okay? So let me write this down so that you get used to it. For fractional index, the numerator is placed as what? The numerator is placed as power, while the denominator is placed as root. So let me state the formula. You have 4. You have a, when you have a raised power of m all over m, this is something else. N roots. Put this n inside. When you are writing, don't write something like this. When you write, don't write something like this. Okay? Okay, you say this is important. Put your symbol, you put M here, you put A here, this is the power of N. So this is what we have. Formula. Okay? So to start example 4. So let's carry on with example 5. Okay? This is example 5. Evaluate. Look at another English. Evaluate. There's not two words in mouse. Evaluate 8 raised by 1 over 3. Solution. And I have 8 raised by 1 over 3 is equal to, apply the rule. You put this symbol, you put 3 here. What should be here? Remember, is the base 8. And what should be here? The numerator, which is 1. So this is something as cube root of 8. And this cube root of 8 means you look for a number. When you multiply it 3 times, why we are going to multiply it 3 times? Because we have 3 there. Okay? Look for a particular number. When you multiply it 3 times, you get 8. So if you get that number, you multiply it 3 times. That particular, pick 1 from the number. That number becomes the cube root of 8. So let's start with 1. Let's say 1 times 1 times 1. 1 times 1 times 1 times 1, you get 1. So 1 is not equal to this. After 1, what's the next number? 2. Let's start with 2. 2 times 2 times 2. 8. So it means 8 should be the answer. 2 should be the answer. Sorry. 2 should be the answer. So we can say cube roots equals to 2 times 2 times 2. So just pick 2 because 2 is the number that when you multiply it 3 times, you get this one, 8. So you just pick 2. So it means 8 raised to 1 over 3 equal to 2. Very easy. Okay? So we still have another example. Under fractional index. So let's start on the example. Let's solve the example. So example 6. Find the meaning. Find the meaning of 4 raised to 3 over 2. Find the meaning. So solution. Every mathematical problem has solution, so you have to state the solution. Okay? So we'll have 4 to the power 3 all over 2. You use this formula given to us here. You put this symbol. What should be here? 2, but it's not allowed to put 2. We already know that it's 2 that it should be there automatically. Your base is 4. Then you put 3 here. Okay, so what is square root of 4? So you look for a number, when you multiply 2 times, you get this 4. 1 times 1 is 1, 2 times 2 is 4. I think 2 should be the answer. So what we should put here is square 2 times 2 raised to the power of 3. So this is 2 raised to the power of 3. Okay, now 2 raised to the power of 3 means 2 raised to the power of 3 equals to 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 2 times 2 you get 4. 4 times 2 you get 8. So this is 8. Okay? So it means 2 raised to the power of 3 equals to 8. Therefore we have 4 raised to the power of 3 all over 2 equal to 8. Okay? So let's talk about the last law, which is the negative index. Okay? That is the 6th law, negative index law. Okay, let's see, we have a raised to the power of 0. Remember, this is under the 0 law. So a raised to the power of 0 equals to 1, because we are told that a number raised to the power of 0 equals to 1. Suppose we have this, and suppose we have a raised to the power of 2. This a times a. Okay? And let's say we are dividing this a raised to the power of 2, a raised to the power of 0 divided by a raised to the power of 2. Okay? So if we apply division law here, we'll be having a raised to the power of 0 minus 2. Okay? Because here is division, so we have to subtract the power. Okay? So this is equal to, what is 0 minus 2? You have minus 2 is minus 2 is a raised to the power of 0 minus 2 is minus 2. So this is what we have. But let's look at it this way. If we have a raised to the power of 0 divided by a raised to the power of 2, this is equal to a raised to the power of 0 is 1, and this a raised to the power of 2 is still a raised to the power of 2. So if you watch the statement here and here, they are the same, but the results are kind of in a different position, but they are the same result. So it means the result here is equal to the result here. So all we are saying is a raised to the power of minus 2 is equal to 1 all over a raised to the power of 2. Because this is the result here and this is the result here. The statements are the same. Okay? So therefore we say we have a raised to the power of minus n is equal to 1 all over. So it means 1 all over a raised to the power of n. It means when you're having minus n, this minus is as if you're having 1 all over n raised to the power of this power here. Okay? So just this is the law. Okay? So this is negative. When we are having negative power, this negative here, when the power is negative, it's just as if you're having 1 all over a raised to the power of n. Okay? So let's take example under it. Okay. So example 7. So we stop at example 6 there. So this is example 7. And this evaluates 6 raised to the power minus 2. So the solution 6 to the power minus 2 equal to, remember what I said, the power here is negative. So this negative, we have 1 all over equals 6. The power here is 2. So you put your 2. Okay? Okay, because 1 all over is 6 is power to me 6 times 6. 1 all over 6 times 6 is 36, right? Okay, 36 there. Okay, so it means 6 to the power minus 2 equal to 1 all over 36. So I think we stop. Yeah, we stop here. Then we go into exercise that comprises all the law. You have to combine. You think, you combine. You don't just watch the question. You have to think and you combine the laws. Anyway, you know that you apply law 2, you apply law 3, you apply, and so on and so forth. Before you finally get your results. Okay, thanks.